A car is moving at 60 miles per hour when the driver notices an obstacle ahead. Hitting the brakes, the driver decelerates at a constant rate and manages to come to a stop just barely before hitting the obstacle. If the car had instead been moving at 70 miles per hour and started decreasing at the same place and the same rate, with what speed would it have hit the obstacle? So, first let's take a look at what we know. For the first part, we know that the final velocity is 0. And the initial velocity is 60 miles per hour. Now, for both of these scenarios, it decelerates at a constant rate. And it decelerates at the same place. So the best equation to use would be this one. The place and the acceleration are the same, and we can easily find the final and initial velocities. So for the first case of 60 miles per hour, the final velocity is 0 miles per hour. So 0 squared is equal to 60 squared. That's the initial speed in miles per hour, plus 2 times the acceleration times the displacement. So we know that the acceleration is negative. Since it's decelerating, it's going to have the opposite sign as the velocity. So we get minus 60 squared equals minus 2a times the displacement, which can be further simplified just to 60 squared is equal to 2 times the acceleration times the change in x. So the initial velocity of the first one is equal to 2 times the acceleration times the change in x. So now that's for the first car. The second car, the initial velocity is 70 miles per hour. And then so we get that the final velocity squared is equal to the second initial velocity squared minus 2 times the acceleration times the displacement. Again, it's a deceleration, so it's going to have the opposite sign of velocity. And then we can simplify this just to velocity, the second one squared, minus the velocity of the first one squared. This is because this part, the 2a times the change in x, we can substitute the first part in for. And that is equal to the final velocity squared of the second case. Now just plug in the values that we know, and then we get that the final velocity is equal to the square root of the second starting velocity, 70 squared, minus the first starting velocity, or 60 miles per hour squared. And then if you solve this, this is equal to 36 miles per hour. And that will be the speed that the car hits the wall in the second scenario.